Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Mardhiah Binti Khairunizan, and today I will be presenting my FYP with the title of a review, Antioxidant Capacities of Ficus Deltoidea Properties. First, we will go through the background of study. So locally, it is known as mascote and it is a member of Moraki family, in which these traditional herbs frequently utilized as for its therapeutic benefits. Ficus Deltoidea leaves also claims to be good for women, in which the boiled leaves of Ficus Deltoidea that can be made as a decoction for mothers to drinks after giving birth. And Ficus Deltoidea contain of phytochemicals that exhibit biological activity such as antimicrobial, anti-inflammatory, anti-allergic, and antioxidants, which contain polyphenols that contribute to antioxidant activity. First, we will go through to the introduction. For the problem statement, while several research and review articles touch upon the antioxidant properties of Ficus Deltoidea, they merely offer a brief discussion on the subject without providing a comprehensive review of the available reports regarding to these properties. Instead, most research articles primarily focus on linking the antioxidant properties of Ficus Deltoidea with other functional properties such as antimicrobial, antidiabetic, and else. However, there is no in-depth review research that has been done on the antioxidant capacities of Ficus Deltoidea. Next is the research question. So the first one is, what are the treatment affecting the antioxidant levels in Ficus Deltoidea? What are the antioxidant values in female and male plant of Ficus Deltoidea? What are the antioxidant values in different parts of Ficus Deltoidea plant? What are the antioxidant values vary in sample preparation method? What are the antioxidant values of Ficus Deltoidea in different types of solvents? And lastly, what are the chemical compounds that contribute to the antioxidant capacities? There are two objectives in this review article. The first one is to review the studies of antioxidant values reported on Ficus Deltoidea, and the second one is to identify the treatment that affect the antioxidant properties of Ficus Deltoidea. Next is the significance of study. The finding of this study provide knowledge about the antioxidant properties of Ficus Deltoidea, which can contribute to the public knowledge. Second one, by exploring different techniques and tests for preparing Ficus Deltoidea for antioxidant analysis, can prove beneficial for future research. And this review study offers an overview of the antioxidant value of Ficus Deltoidea concerning the plant sexes and the plant parts. And lastly, understanding the diverse preparation methods and treatment that influence the antioxidant value of Ficus Deltoidea is essential for maximizing its nutritional benefits. For research methodology, according to the preferred reporting items for systematic reviews and meta-analysis (PRISMA), this study has been conducted to conduct a systematic review of the literature based on the analysis of paper concerning the latest antioxidant capacities of Ficus Deltoidea characteristics. As you can see, based on the table, it is the inclusion and exclusion requirement in selecting the research articles for this review paper. Next is this is the figure of the flow diagram in selecting the research article. So basically the database gain is 275, which is 138 is from Web of Science and 137 is from Scopus. However, after the screening and eligibility, the included research journal or research article that included in this review paper is only 49. Okay, we will go through the overview and phytochemical compounds of Ficus Deltoidea. So basically, methyl sulfate of Ficus Deltoidea is known as Kankaliba in Central Africa, while Tapak Barito is known in Indonesia. And in Malaysia, we call it as Mastrotate. And its usage as a traditional disease preventive herb and also being consumed as a tea, a tonic tea, and also supplement throughout Malaysia. And Ficus Deltoidea plant contains powerful natural antioxidants such as flavonoids, triterpenoids, proanthocyanins, phenols, and tannins. Next is the treatment enhancing the antioxidant levels in Ficus Deltoidea. So there are two treatments, which is hydrogen peroxide, H2O2, and nitrogen fertilization. So hydrogen peroxide is basically present naturally in plants, but due to the plant early phase low growing issue, the hydrogen peroxide also employed as an alternative therapy to stimulate the growth, photosynthesis, and other psychological process. And this finding shows that the treatment plants, the TPC and the TFC, were greatly enhanced due to the use of hydrogen peroxide. And this might be because of hydrogen peroxide acts as a signal molecule throughout the synthesis of phenol. As for the ABTS activity, the values reported ranging from 3.08 millimole trolox per gram to 3.94 millimole trolox per gram, with a rise in the hydrogen peroxide treatment concentration, which indicate that the result of the treated and untreated plants of ABTS antioxidant assays were not statistically different from one and another. However, for the nitrogen fertilization, according to the finding, in comparison to stem and roots, leaf shows the higher antioxidant activity across all treatments. And up to treatment 3, the trend of rising antioxidant activity increased along with the nitrogen fertilization, but once its level was reached, increasing fertilizer rate caused a decrease in antioxidant activity throughout all plant organs. And lastly, optimal nitrogen fertilization levels are crucial for maintaining antioxidant capacity in plant, as excessive nitrogen levels can have detrimental effects on growth and antioxidant activity. This is the table record of the selected journals. Next is the antioxidant values in female and male plants of Ficus Deltoidea. So basically, Ficus Deltoidea plant family separated into two types of plant, which is the male plant, which known as Ficus Deltoidea variation Antioxidant, and the female plant Ficus Deltoidea variation Deltoidea. As you can see on the left side of the slide, the female leaves have a thick and wider leaves compared to the male leaves, which has a long and thin leaf. And female plant is more efficient since it has a better antioxidant capacity and can scavenge more free radicals. The extracted from female leaves, which have a higher concentration of flavonoid and phenolic components, was more antioxidant active than male leaves. And all the studies indicate that the female leaves to have higher antioxidant activity to be compared to male plant. However, based on the research articles gathered, there is still no substantial reason to justify how and why female plant have more antioxidant activity than male plant. This is the study gained and collected for female and male plant. Next, we will move to antioxidant value of Ficus Deltoidea in different parts of plant, and we will go through the leaves first. As Ficus Deltoidea became older, up to 12 months old, antioxidant activity increased in a trend that was synchronous with it. And in addition to the ages of leaves, the drying temperature is significantly affecting the antioxidant capability. The amount of flavonoid chemicals extracted vary significantly depending on the size of the Ficus Deltoidea leaves, and there may be a significant variations in the amount of extracted phenolic and flavonoid chemicals depending on the leaf surface area. And the antioxidant properties of Ficus Deltoidea leaves vary depending on the factors such as leaf maturity, cultivation conditions, leaf size, and drying temperature. Next is the fruits. For the fruit extract exhibits significant TPC and TFC, indicating the presence of phenolic compounds and flavonoids. TPPH, IC50 values tend to decrease as the fruit mature, indicating an increase in antioxidant capacity with ripening. And findings highlight the potential of Ficus Deltoidea as a valuable source of antioxidants, with a variation observed based on the fruit maturity and variety. Next is stem. The antioxidant values including TFC and DPPH, IC50 vary among the different types of stem and the duration after planting. Cultivated stems generally exhibit a higher DPPH IC50 values compared to wild stems, while TFC values appear to be higher in cultivated stems. The antioxidant activity IC50 and TFC values shows an increased amount of antioxidant as the age of the plant increases, and this research shows that stem extract has a weak antioxidant activity compared to leaves and fruits extracts. Next, we move to antioxidant values varying in sample preparation method. As for both FRAP and DPPH assays, leaf extract had a high antioxidant capacity than the cell suspension culture. And according to the study, the phenolic content may vary depending on the variety employed, despite the similarity of the species used. Moreover, Ficus Deltoidea variation Kusleri has the highest flavonoid content and antioxidant capacity among the sample studied. And lastly, Ficus Deltoidea version angustifolia fruit extract has a higher antioxidant activity based on the LBTS assay compared to the Ficus Deltoidea version Kusleri fruit extract. remove the antioxidant value in Ficus Deltoidea in different types of solvents. Methanol extraction often resulted in high TPC values, followed by ethyl acetate and hexane extractions. Hexane and methanol extraction often yielded higher TFC values compared to other solvents. However, compared to the crude water extract and ethyl acetate fractions of the fruits of Ficus Deltoidea, the flavonoid concentration found in the hexane extracts was significantly lower. Ethyl acetate and methanol extracts often exhibit high antioxidant activity in DPPH compared to other solvents, and Ficus Deltoidea alcoholic and aqueous extract showed strong antioxidant activity against DPPH and displayed promising antioxidant activity. And lastly, among the solvent extractions, the methanol extract often exhibits the highest antioxidant activity in the FRAP and ABTS assays, followed by the hexane and ethyl acetate extracts. And for the last point of this review article is chemical compounds that contribute to the antioxidant capacities. There are two compounds, which is phenolic compound and flavonoid compound. For phenolic compound, Ficus Deltoidea contains a significant composition of phenolic compounds, constituting approximately 27.12% of its composition, in which highlights that the prominence of phenols as one of the major antioxidant constituents in Ficus Deltoidea. As for flavonoid compound, flavonoids with antioxidant properties such as vitaxin and isobitaxin are found in the intercellular plant cell. And the Ficus Deltoidea version angustifolia may possess greater antioxidant potential attributed to its higher isobitaxin content compared to the other varieties analyzed. However, for vitaxin content, the Ficus Deltoidea version consuleri may possess high antioxidant potential attributed to its high vitaxin content compared to the other varieties. As for conclusion and recommendation, factors like plant's gender, in which female plants have high antioxidant activity compared to male plant components showed that leaves exhibit high antioxidant values compared to the fruits and stems, and the type of solvent applied shows that methanol and hexane solvent have a higher antioxidant than other solvent used can be concluded. Next, hydrogen peroxide also acts as a signal molecule, influencing the synthesis of phenols and contributing to increased total phenolic content and total flavonoid content in the plant. In order to assess the efficacy and potential effects of its antioxidant in terms of disease caused by oxidative stress, further in vivo studies as well as human trials should be undertaken. And future research should focus on further elucidating the mechanism underlying these findings and providing more conclusive insights into the impact of hydrogen peroxide treatment on antioxidant values in Ficus Deltoidea. This is my reference used in this review article. That's all from me. Thank you.